Right, okay, let's look at these examples. A discrete random variable t has a cumulative distribution function. Right, it's giving you the cumulative distribution function as follows. So given that this information, and find the probability of distribution of t. Right, usually when this is a discrete random variable, it's a discrete random variable. So when they talk about probability distribution function, we will usually represent the probability distribution function in the form of probability distribution table. Alright, usually we were doing that. So it will be a lot easier. So it means that when they said find the probability distribution function, we can also just assume that they are asking us to find the probability distribution table, construct the probability distribution table, and this is the cumulative distribution function. Alright, okay, let's see how to using the information given. Okay, before that, definitely we need to rewrite. We have to do this, rewrite this into the cumulative distribution table. It will be a lot easy. Alright, how to transfer. Okay, at this video, I'm going to tell you how to transfer a cumulative distribution function into a cumulative distribution table. Alright, okay, I'm going to draw here. So then we're going to identify how many. Okay, in this case, it's t, right? The random variable is t. So, and this will be your ft, right? ft. So, how many discrete random variable here for this case here? So less than 1. So means we start with 1. Alright. If you see there is an equal, so I just tell you what to do. Alright. So if there is equals to 1, so means that you start with 1. Alright. Start with 1 and followed by 3. Alright. Equals to 3. So then the next one will be 3. This is the way you transfer. There are no value of 2 here, right? You can't see the value of 2 here, right? So equals to 5. So you put 5 here. 5. And later on, equal to 7, right? So then you put 7. And lastly, equal to 9. Right? And with 9, right? 9. So from here, and later on, so how to find the value of 1, right? F1. So means that the probability before 1, right? Before 1. So before 1, alright? So this is already after 1, right? So which is k. So you just transfer, right? Without just transfer here. When there's t that equals to t equals to 1, then you put in k, and t equals to 3, and you have 3k here, alright? 3k. So and 5, you will have 8k. 8k, and 7 you will have 12k, alright, 12k, and lastly it will be 1, right? Now I have rewrite the cumulative distribution function into a cumulative distribution table. Alright, you must know how to rewrite this. Okay, very simple. You look at, there is an equal here, so start with the value of 1 and equal 3. There are no 2 here, right? So 1, 3, equal 5, equal 7, equal 9. Then you have 1, 3, 5, 7, 9 as the discrete random variable. Then what is, so when t is equals to 1, can you see that the k here? This means that f1 is k, right? F equals 1, f1 is k. So it means that f1 is k. So followed by t equals to 3, right? It will be 3k. And you just transfer all this into the cumulative distribution table, right? And later on, the question is actually giving us the information, right? Given that the probability of t, right? T between 4 and 8, right? Will be 3 over 5. It's between 4 and 8. Include the 8. Alright, so very simple. So of course, this information is actually helping us to find the value of k here, right? The value of k here. So from here, you have learned from the previous video, I have talked about what is the meaning here. So you know that the total probability from t equals to 1, right? Plus pt equals to 2, 3, there are no 2 here, 3. Probability of t equals to 5, plus with probability of t equals to 7, plus with probability of t equals to 9, right? Total up everything here. If you total up 1, 2, 3, the total probability of this 5 random variable, you were getting 1, right? You were getting 1. But based on this, okay, based on this, so the probability between 4 and 8, include the 8. So which is the one, right? Between 4 and 8. Cannot be 4, alright? It must be 5 and 7, right? 5 and 7. So means that t less or equal 8, right? But there are no value of 8 here, right? There are no value of 8 here. So means that 7 and 5, right? 7 and they just want the value of 5 and 7, right? Anything between here, right? Cannot be 4, cannot be 8, right? So, and you know that this will be equals to, because you just want these two, right? You just want these two. Means that it's f, you're adding up, right? You're adding up everything here. Up to 7 here is meant by f7, right? f7. You add up all this f7. But you have to minus away this one, right? You have to minus away this one. Because you just want 5 and 7, right? So you have to minus away f3. 1 and 3. So it's cumulative up to 3. So what is f7? f7 is 12k, right? It's 12k, right? So the probability between 4 and 8 will be f7 minus f3, right? Because you just want 5 and 7. So you're taking f7 minus f3. So then you're getting 12k. You're getting the 12k, f7, minus away f3, which is 3k. 3k. And after you minus, you are getting the value of 9k, right? 9k. And the 9k is actually given, right? This whole thing probability is 3 over 5, right? It's 3 over 5. Very simple. So from here, you can find the value of k, right? Which is k equals to 3 divided by 5, right? Divided by 5. And divided by 9 means multiply a 9 here, right? So 3, 3, 9. Later, you will have k to be 1 over 15. So this is the value of k. So which means that k is 1 over 15. Okay, now I have know the value of k is 1 over 15. And I want to rewrite. I want to put this into the cumulative distribution table. Alright, since you know that the value of k is 1 over 15. Right, 1 over 15. So I'm going to redraw this. So the probability, okay. So this will be t, ft. So you have 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. And the k value will be 1 over 15. So you will have 1 over 15. And this will be have 3 over 15, right? As 3 multiplied with 1 over 15. And this you have 8 over 15 and followed by 12 over 15, right? And finally you're getting a 1 here, right? Okay, now I have known the value of k, right? And the question is asking us to find the probability distribution function of t, right? So how to find the probability distribution function of t is actually meaning to find the probability distribution table. Okay, it's a lot easier to explain. So because this is a discrete random variable, so it's easy for doing this. So so probability of t equals to t. Alright, probability of t equals to t. So you have 1, 2, 3, 1, 3, 5, 7, 9. How to find the probability of t equals to 1? Very simple. You can just directly taking here. So 1 over 15, right? 1 over 15. Whereas for this, pt equals to 3, you're taking the 1 for this, f3 minus away f1, which will be 3 over 15 minus 1 over 15, you are getting 2 over 15, right? Followed by 5, right? The probability of t equals to 5, you are getting 8 over 15 minus with 3 over 15, which will giving you 5 over with 15. And for 7, probability of t equals 7, you're taking 12 minus with 8. So you are getting 4 over with 15, right? 4. And finally, 1 minus 12 over 15, right? 1 minus 12 over 15. So it will be 3 over 15, right? If you total up this probability, this is a probability distribution function. If you total up, you are getting 1. You see, everything is over 15, right? So you're taking 1 plus 2, 3. 3 plus 5, 8. 8 plus 4. Right, 8 plus 4 will be 12, 12 plus 3, 15. 15 over 15, you are getting 1, right? So this is a probability distribution function, right, of this, right? I hope you understand how to answer that question.